Okay guys, it is a beautiful sunny day out here on the off-grid property. The solar panels here are taking in a ton of energy, but the problem is the house is dead. We have no power. This is our Ames 48 volt inverter charger that is no longer working. Sadly, this inverter is only 3 years old. But today we're going to be installing the new EG4 3000 watt off-grid inverter charger. The Ames 48 volt inverter charger was $950 new. The EG4 3000 watt off-grid inverter was only $674. The cool thing about this EG4 is it is a charge controller and inverter all in one. This is an amazing inverter, and if you're concerned about cost like I am, this is the way to go. Keep in mind that this EG4 3K inverter is compatible with several types of batteries, one of them actually being flooded batteries or what they call lead acid, which is what I have. You may have seen in other videos where I installed this same inverter with EG4 batteries that are lithium. Okay, so let's get going. We've already removed the inverter. Now we just need to remove the charge controller. Okay, so the first thing we've got to do is kill all the power coming from the solar panels. Woo, look at these keys. Completely rusted. Hopefully it'll open. Sure no wasp in it or something. Okay, we're just going to kill the main power going to the existing charge controller. Okay, now that we got the old charge controller and inverter out of the way, we need to figure out a good place to put this new EG4 inverter charge controller in here. Woo, it's nice and hot out here today, right at 100 degrees. Okay, so this wiring coming in here in the back here is the wiring that goes underground to the house and the wiring that goes to the generator. Now I had to hook these two together when the inverter went out so we would have some type of power. And this is for the backup for like when the power gets too low and we've had a few cloudy days and we need to use a generator. And this 8-gauge wiring here runs underground and directly to the cabin and up into the fuse box. Then over here we have all of our DC power that's coming in from the solar panels. We have the positive here and the negative here, and then we have the two grounds going to the ground rods. On the bottom of the EG4 here, we have the AC input, the AC output, and the solar panel input. The AC input in my off-grid situation here is going to be the generator. And the AC output here is where I'm going to be running the 8-gauge wires that are running to my house. Over here we have the positive and then the negative coming off of the 48 volt battery bank that we have. This is the on and off switch for the inverter, and this right here is the circuit breaker. This right here is where our ground's going to be connected. I believe the RS-232 cable is going to be what goes to the EG4 batteries if you decided to purchase that type of battery. It allows the batteries and the inverter to communicate. There's a nice feature. This one has dual fans. Okay, first let's make sure that we don't have any voltage coming in from the solar panels. We have it shut off. Yes, 0 volts. So just to verify that, we're going to turn the panels on and see what the voltage is coming in now. Okay, I flipped the breaker up on it. Let's see what we got here. Be careful, don't want to get lit up here. 70 volts. Okay, while I'm installing this, I'm going to let you know real quick that this EG4 inverter came with the positive and negative cables that you can run directly to the battery. And it also came with an inline breaker. This is going to be like a 48 volt 125 amp DC breaker. This is the rail that it came with. Okay, let's go ahead and get the positive and the negative cables installed that are going to go directly to the battery. Next, let's get the power that's going to run to the house with the 8-gauge wire running in here. This is going to be AC out. So, with that being said, we're going to go ahead and hook in our, what we call the generator wire. We'll go ahead and get this thing ran up in here, and then we'll run these two grounds together in here. Okay, let's get these wires kind of lined up where they look a little better. Okay, the next thing we're going to do is hook up this breaker. It's pretty simple. This just slides through like this. We're going to mount it down here to this board here, run the positive wire in it here, and run the positive wire back out of it here. It's going to go to the battery from here and the inverter from here. And this way you'll be able to cut off the battery power from the inverter at any time you need. Okay, the last thing to do on the inverter is to get the panels hooked up and get this solar ran into here. Okay, we're gonna slide this negative back in. Okay, let's put the cover back on. We're finished in here. Ooh, it's kind of been a hot few hours hooking this thing up. I think all we have left now is to hook the inverter to the battery. Let's test and see what our voltage is, by the way, before we even hook the positive up. It's gonna be here. 52 volts. Okay, we'll get this positive tightened down here. Okay, we got these wires tidied up a little bit, and we're ready to go. Let's go around the back side there and hook up the AC output, and then we can turn it on and see if it works. I should have probably got a bigger box than this. We're going to see what we can do. This will get us by for right now. Not too concerned since this is direct burial cable. Okay guys, I'm ready to turn this thing on and see how it works. EG4 recommends a sequence to turn this thing on. I'm going to show you what that sequence is. Okay, the first thing we want to do is give it power from the batteries. This is the 48 volt battery bank. And we're going to turn the power on here and give the inverter the 48 volts. Now once the power is actually running into the inverter, we're going to turn the on switch on the inverter, which is located underneath here. Okay, we do have power. We're showing 121 volts right now. I do know that the house is going to be pulling some power. The air conditioner is on. The input is 0. We have not even turned the solar panels on yet. The sun is down anyways. I'm showing 50.8 volts. It's got a 6% load on it. 506 watts are being pulled by the house right now. Okay, so we're going to go ahead and set this thing up for the lead acid batteries. Before we do that, let's go ahead and turn the panels on. Now let's see what kind of wattage is coming in. PV input shows nothing right now as far as watts. So there's something going on there. So now I've got a little bit of work cut out for me. On the other charge controller that I was using by Morningstar, it allowed me to have 48 volts to 120 volts. The EG4 inverter starts at 120 volts and will take all the way up to 500 volts. Now this is DC we're talking. So I've got about 72, 73 volts coming in, something like that. Because I have two panels that are wired together, they're 24 volt panels, which makes 48 volts, and the open volt circuit is somewhere around 72, 73. So with the EG4 requiring 120 volts for it to even register, I've got a whole lot of rewiring I have to do here. So that's going to be a little bit of a drawn out ordeal, so I'm going to go ahead and get that done, and I'll be right back with you. Okay, it is the next morning. Last night off of camera, I have completely rewired and reconfigured my solar panels. I'm going to show you how I wired them and how it works best with this EG4 inverter. Okay, each one of these panels is a 24 volt panel, and we have 6 of these panels. The way we have them wired is we take the positive from this panel and bring it to the negative of this panel, the positive from this panel to the negative of this panel, positive to negative, and positive to negative. So what we end up with is a negative here that comes out on this end. Then when we walk back down here to the other end, we have the positive lead that comes out here. Before, I had 2 panels wired together. They were 24 volts each, which made 48 volts. So there's a total of 12 panels here, 6 of them wired in series, and the other 6 wired in series. And then each bank of panels of 6 are wired together in parallel. The charge controller always asks for the VOC, which is a volts open circuit. That means how many volts are the panels producing without any load upon them. On these panels, the VOC is 40.3 volts. So we're going to take 40.3 and times it times 6. That's going to give me 241.8 volts. Now this is 241 volts, this is 241 volts, but when we wire them across in series here, they're going to stay 241 volts, but it's going to raise the amps and it's going to raise the watts. Now we're going to step in here and see what the inverter's doing. It shows that we're pulling 1,390 watts, 7 amps. So with the load on it, the panels are pushing 180 volts to charge the system. It's an inverter, it's a battery charger, and it's also a charge controller that controls the charge going to the batteries. All this in one. Under $700 for an all-in-one inverter, that's amazing. If you're off grid or thinking about going off grid, or if you just like to have a backup system at your house for when the electric goes out, there'll be a link in the description on how to purchase this exact EG4 3000 watt inverter. I'll also leave an email if you'd like a parts list and how to build your own system.